Good afternoon, students. Today we will be discussing about the how to determine the rate constant, that is BOD rate constant, and the ultimate BOD, which is also denoted by L naught. Okay, that means the amount of organic matter left in the wastewater when the time was 0 days or when at the beginning. Okay, so that is called as your ultimate BOD. So today we will discuss how many methods are there for their determination, and then we'll discuss mainly two methods which are mostly used, okay, or which are mostly accurate. All right, so without any further delay, let's start. Okay, so there are for the determination. Okay, so for determination of K and L naught. Okay, what is K? K is BOD rate constant. Okay, BOD rate constant, and L naught is your ultimate BOD. Okay, so how to determine this? Okay, generally, see, you have already studied the formula, that is which is, if you want to find BOD at time t. Okay, so BOD at time equal to t days. Okay, so how to find? That is given as yt equals to L naught 1 minus 10 to the power of minus kt, or L naught 1 minus e to the power of minus k dash t. Okay, so you know this thing, and k equals to k dash by 2.303. so these things were covered in the previous lectures. Okay, so by now you should know all these things. All right, so today we will see how to determine the values of your BOD rate constant, okay, and also how to determine the values of ultimate BOD. Okay, now there are many methods. Okay, I'll list out some of the methods which are used for the determination, okay, of rate constant and ultimate BOD. Okay, so there are various methods. Okay, and the values of ultimate BOD, okay, or which is approximately equal to 20-day BOD, and rate constant can be computed from a series of BOD measurements at various times. Okay, so they can be calculated from a series of uh, experiments, okay, or measurements of BOD at different time interval, okay, at different days. Okay, so the usual methods which are used for computation of your rate constant and ultimate BOD are, okay, I'll write in the next page. Okay, methods for determination of K, and these are methods. Okay, determination methods for K and L naught are: number 1, method of least square. Method of least square, this is the most accurate method. Okay, this gives the most accurate results. Then second is Thomas Slope method. This is your graphical method. Okay, Thomas Slope method is your graphical method. Then third This is the second most accurate. Okay, second most accurate. Okay, third method is method of moments. Method of moments. Fourth method is Fujimoto method. Fujimoto method. This is graphical method. Okay, Fujimoto method is a graphical method. Graphical graph is plotted and two graphs are plotted. Okay, and those two graphs, at the point in which they are intersecting, that point is your ultimate BOD. Okay, so by Fujimoto method. So and then you have your rapid ratio method. Okay, there are different methods. Okay, rapid ratio method, rapid ratio method, and last is your method of daily difference. Okay, or daily difference method. Okay, so these are the different methods for determination of rate constant and ultimate BOD. But the most important methods which we will be discussing, or which you need, okay, in your according to the syllabus, is your method of least square and Thomas loop method. You no need to study all the methods. Okay, so these two are the most accurate methods. Okay, so that is why their analysis and their understanding is very necessary as a civil engineer. Okay, all right. So but we'll discuss these two methods. So starting with least square method, but derivations and all those things is not necessary at this undergraduate course. Okay, only their formula and how they are calculated. Okay, if you are asked numericals on those, then you must be able to solve. Okay, so derivations and all those things is not necessary and at your undergraduate level. Okay, sorry, at the graduate level, at your BTech level. Okay, all right. So what is first is your method of least squares. Okay, so method of least squares. So what is method of least square? Method of least square involves fitting of a curve. Okay, just listen to the words properly. Okay, methods of least square, this method involves, what it involves? Fitting of a curve. Okay, involves fitting of a curve, fitting of a curve through a set of observed data points. Okay, through a set of observed data points. Okay, through a set of observed data points. Okay, but there is condition. Okay, in such a way that sum of the squares of residual is minimum. Okay, alright, so I think it is gone. Okay, but okay, let me again go back. Okay, so first was this, we are studying about method of least square. Okay, so what what is your method of least square, what this method tells you. So it involves the fitting of a curve through a set of observed data points, okay, through a set of observed data points, but there is a condition, okay, provided sum of squares of residual is minimum, okay, provided sum of squares of residual is minimum, okay, provided sum of squares of residual is minimum. Okay, I think you have understood what I am telling. Okay, so this is involves curve fitting, through a set of observed data points, provided the sum of squares of residual is minimum. Okay, I'll come to it properly. First understand what is residual. Okay, residual is equal to the difference between observed value and value of the fitted, and the value that is fitted in the curve. Okay, so residual, what is residual? Say residual, you have got this term here. Okay, residual. So what is residual? Residual equals to difference between the observed value and value of fitted curve. Okay, and observed value and fitted curve value. Okay, that means, for example, let's say I want to plot a graph. Okay, x-axis, y-axis. So let's say I have got some points here. Okay, so this is one point, okay, so I have got one point here also, some points here. Okay, so now a graph is fitted. Okay, let's say maximum number of points are covered. Okay, so this is a graph which is fitted. Now you see there are some points which are not lying on the graph. Okay, these points are not lying on the graph. So now what they are saying is that method involves fitting of a curve through a set of observed data points. Okay, so we have observed these points are observed points. Okay, so through these observed points a curve is fitted. Okay, provided the sum of squares of the residuals is minimum. So the sum of squares, okay, so sum of the squares, so let's say square of this point or any residual point, okay, plus the square of other residual points should be minimum. Okay, what is residual? Difference between the observed value and the fitted curve. Okay, so there are some observed values. Okay, so you will find observed values. So what happens is that, what is residual? Okay, so this, let's say the one point is this observed value. Okay, this is our observed value, but the graph is being fitted through this point. Okay, so this difference should be minimum. Okay, so this is residual. Okay, this difference is your residual. Okay, but in this case that difference should be minimum. Okay, sum of squares of the residuals should be minimum. Alright, so that means That means if this is a curve, sorry, if this is a graph and you have plot a curve, okay, and there are many points, okay, and there will be some data points lying in and around the curve, okay. So then residual means difference between this point, which is your observed value, with the fitted value. Let's say this is your fitted value, so this difference between the observed value and the fitted value is called the residual, okay. So this difference is called as the residual, okay, and it should be minimum, not directly, but the sum of the squares of the residual, okay. So square of this distance, square of this residual, square of this, okay, and if you add all these residuals, then their sum should be minimum, okay, minimum as possible, okay. So this is what your least square method is, okay. You don't need to, it's not required to learn in details, but at least you should know what or how the things are in your the method of least square, okay. Okay, so moving on, remember one thing here, okay, which is if dy by dt is the slope of the curve, to be fitted through the data curve, then dy by dt t equals to n will be given by k dash l naught y n, okay. Alright, what is n? T is, you know, it's duration, time interval, okay, time in days. What is n? Number of data points, okay, n equal to number of data points, okay. So then there are some derivations, okay. So this is deriving and then taking some experimental error on both sides, so all these things, and then at the end we'll be getting two equations, okay. We'll be getting two equations, which are, I will directly write the main formula, okay. You don't need to study this in details, okay. Only the main formulas are very important, so those things you should know, okay. Alright, so for each set of data, following equations are used, okay. They are, now I will write the equations, okay. So this is n a plus b summation of y minus summation of y dash Y dash means it's derivative, okay. Dy by dt is y dash, okay. Differentiation of y with respect to t, okay. Dy by dt is y dash equals to 0. This is your one equation, okay. And there is one more. These are simultaneous equations, okay. Summation of y square minus summation of y dash equals to 0. So you have to solve these two equations, okay. Then solving these two equations we get a value, okay. So what value we get, okay, you can note this down, pause the video and note this down, okay. So solving equation 1 and 2, we get what we get k dash equals to minus b. This is one formula, okay. And L naught equals to minus a by b, okay. So this is another formula, okay. And also you know this k equals to k dash by 2.303. So once you know k, you can easily find, once you know either, okay, if you know k or if you know k dash, you can find the other one also. So in this case we know how to calculate k dash, so we can easily find k, okay. So which is equals to minus 0.434 b, okay. Alright, I'm just substituting this value, okay. The value is just being substituted. See, k dash, okay. So k dash is minus b, okay. So this negative is coming here, b is coming here, okay. And 1 divided by 2.303 is this, 1 by 2.303 is 0.434, okay. So this is how 0.434 is coming, okay. Okay, alright, moving on. Also slope equals to dy by dt, okay. Differentiate y with respect to time, okay. Dy by dt is computed by, okay, just a moment, equals to or y dash equals to, let me write clearly, or y dash equals to y n plus 1 minus y n minus 1 to delta t, okay. So this is another equation, okay. Alright, so this is another equation, so you can call it as equation 3, okay. So we'll be using this equation while solving numericals, okay. And also these two equations will be used while solving numericals. Okay, and this is also important. This already you know, but these will be used for solving numericals. Okay, so when we will solve numericals, you will have a better understanding of this thing. Okay, of this formula. But here I will tell you something. Okay, some important informations I will tell you. So let's see one thing. Okay, one very important thing here. What is delta t? Okay, delta t is your summation of the time. Okay, so there are different days. So for example, there will be time. Okay, time in days. Okay, so time will be 1 2 3 4 like that. These are days. Okay, and then what is delta t? Delta t will be some delta 1 delta t1 plus delta t2 plus delta t3. Okay, like that. So at y, let's say for example, let's take an example. I'm solving for time t equals to 2 days. Okay, so time here equal to 2 days. Okay, so I'm solving this example. Okay, so I'm solving at time equals to, so I'm solving for a data point which is at time equals to 2 days. Okay, I'm solving at a data point at which the time equals to 2 days. Okay, so in this case, how to find delta t? Okay, so delta t will be, so since I'm calculating for this at 2 days, okay, since I am calculating at 2 days, okay, so here just a moment. Okay, so since I am calculating at this time interval, okay, that is equal to 2 days. All right, so what will be your delta t? Delta t will be delta t1 plus delta t2. Okay, so delta t1 plus delta t2. Okay, so generally, okay, this is different. Okay, so generally delta t is also you can write it as delta t1 plus delta t2. Okay, delta t1 plus delta t2. All right, so for example, okay, so I think it's better to focus on this when there is a proper numerical. Okay, so then I'll be easily able to explain. Okay, but here we don't have the time set. Okay, we don't have a particular data set, so that is why it will not be clear for you to understand. Okay, but just remember this thing. Okay, and n is the number of data set, and what is y? N plus 1 means, let's say you have let's say here I am calculating y, this is y. Okay, so then y n plus 1 will be this value, n minus 1 will be this value. Okay, because since this is y corresponding to 2, this is y, so n plus 1 will be this, and n minus 1 will be this value. So this will be clear when we solve a numerical. Okay, so just you remember the formulas. Okay, all the formulas that was given. Okay, so this formula you remember, this formula you remember, this formula you remember. Okay, and then finally this formula you remember. Okay, then it will be clear. Okay, when you solve the numerical. All right, Okay, so we'll move to the next method. Okay, so the next method is Thomas Loop method. Method number 2 is Thomas Loop. Okay, method number 2 is Thomas Loop method. If you want to go through the formula again, okay, I am just showing you. Okay, so you can read this. Okay, you can read this. Okay, you can go through it once. If you don't, means if it is okay for you, then you can forward the video. Okay, this is for the students who have missed or who has just has joined this video and they're confused, so you can go through it one by one. I'm just showing it again. Okay, okay, all right. So we'll start with the Thomas Loop method. Okay, just give me 2 minutes. Okay, just give me 2 minutes, and I'll be starting the Thomas Loop method. Okay, just wait 2 minutes. Okay, all right. Sorry for the interruption, students. Okay, so we'll start with the Thomas Lope method. So it's a graphical procedure. Okay, the procedure is graphical. Method is directly not graphical. The procedure of this method is graphical. Okay, procedure is graphical. Okay, and then a formula was developed, approximate formula was developed. Okay, so this formula is given as, the formula is given as BOD for time equal to t days, which is also represented as YT equals to L naught. So I'm writing it properly, little bit below. So BOD at t days, also represented as YT, equals to L naught K dash T multiplied by 1 plus K dash T divided by 6 to the power of minus 3. Okay, so this is linearized. Now this equation was given by Thomas. Okay, approximate formula. Now linearizing this equation. Okay, now linearizing the equation, we get, okay, you don't need to properly learn how to linearize and all those stuff, just remember these things. Okay, linearizing the above, at this level you no need to learn all those things. Okay, we get what we get t equals to yt, t divided by yt to the power of 1 by 3 equals to k dash L naught 1 by 3 minus k dash 2 by 3 divided by 6 L naught 1 by 3 into t. Okay, alright, so this is how the things are done. Okay, so this is the complete equation. Okay, so this is what we will be using. Okay, now from this equation can be also represented as, or it has a form of equation of a straight line. Okay, you can see what is the equation of a straight line. Equation of a straight line is y equal to mx plus c. Okay, so this c is your intercept, this is your slope, right? This is the equation of straight line. So mx is your, mx you can find, m is the slope, okay, and c is your intercept. Sorry, your m is the slope. Okay, m is slope and c is your intercept. Okay, so this is the equation of straight line. So if we plot this in a graph, we obtain a straight line. So a straight line is obtained. So how to plot? If you are plotting this graph, okay, if this graph is being plotted, where in the x-axis you have time, that is t, in days. Okay, always time in days. In BOD, in the concept of BOD, time in days, and you have t by yt. Okay, you have t by yt to the power of 1 by 3 in your y-axis. Okay, So this will result in a straight line. This will result in a straight line. Okay. Alright. And then this is your A equals to, okay, so I will come to this. Let me just go back to the previous slide. Okay, so this is the form in, this is the straight line equation. Okay, you can represent this equation in the form of a straight line equation. Okay, or you can also represent it in this form also, or z equals to a minus bt. Okay, z equals to a minus bt. Okay, either or, you can use this one also, you can use this one also, no problem. Okay, z equals to a minus bt, where z is your t, yt by 1 by 3. Okay, a is your intercept, which is given by k dash l naught minus 1 by 3, and b is the slope, which is given by k dash 2 by 3 divided by 6 l naught 1 by 3. Okay, so in short, this portion is your slope. Okay, and here it is b, this is your a, and this is your z. Okay, or you can also write this is the intercept, so intercept is your c. Okay, so intercept is your c. Okay, b is your slope. Okay, b is the slope. Alright, I hope you have understood this. Okay, so then I'm going to this graph. Okay, so this is a. Okay, this was your intercept, so a is given as k dash l naught to the power of minus 1 by 3. Okay, and then we will find the slope. Okay, let's say we want to find the slope between these 2 points. Okay, what is slope? Slope, how can you calculate slope? Slope is denoted by m. Okay, which you can also find it as tan theta equals to tan theta, or it is also equals to y2 minus y1 divided by x2 minus x1. Okay, slope is also given by tan theta. Also you can find y2 by this, y2 minus y1 divided by x2 minus x1. Okay, so this is your k dash 2 by 3, and your x-axis distance between two x-axis points is l naught by 1 by 3. Okay, alright, so how slope is obtained? So you know tan theta equals to perpendicular by base. Okay, so this is theta. Okay, so this by this you can easily get your slope. Okay, so this you can either get by tan theta also, or you can use y2 minus y1 divided by x2 minus x1. Okay, so alright, so solving this, okay, so once you solve this, you will get, once you know the values of a and b, okay, so now see, so a straight line is obtained, okay, so which is having intercept equals to a and at time equals to t equals to 0. Okay, so intercept at time here, okay, time here is 0. Alright, so this is your intercept, so time is 0 days, and slope you have already got. Okay, so now knowing the values of a and b, comma, we get k dash equals to 6 b by a okay, and L naught equals to 1 by k dash a cube. Okay, and then you also know that how to find the relation between base 10 and base e rate constant, k equal to k dash divided by 2.303. okay, so here if you substitute, you check this one, if you substitute this value, okay, so I will get 2.61, solving and substituting I will get 2.61 like this. Okay, so this is how I am finding the values of L naught, k dash and k using Thomas slope method. Okay, there is one more point to be remembered, note for you. So the data which is best is generally that falls between t equals to 2 days to t equals to 10 days. Okay, so the best data according to this method, best data is the one which falls between time t equal to 2 days to time t equals to 10 days. Okay, at time t equals to 2 days to time t equals to 10 days. So this is a note for you. So best data by this method is the one in which the data falls between time t equals to 2 days to time t equals to 10 days. Okay, alright, so you can again go through this Thomas loop method. Equation was given by this. Okay, then once you linearize this equation, okay, procedure is graphical. Once you linearize this equation, then you will get the equation of this form. Okay, so this is a, if you observe carefully, so this is the equation of a straight line where y equal to mx plus c. M is the slope, c is the intercept. Okay, this also you can either use this, or you can represent this equation with this form also, that is z equals to your a minus bt. Okay, so why I have written here minus, because this in this equation there minus is there. Okay, so you can write like this also, plus, and then you can hold it. Okay, so that's up to you. Okay, if you want to maintain the equation of slope straight line y equal to mx plus c, you can write like that also. Okay, for the time being I will remove this. Okay, and then you see z equals to this. Okay, a equals to this and b equals to this. Okay, like this you can uh, represent. Okay, and then a graph is plotted, okay, to show you actually how things are done. So in y axis you take your t by yt, okay, which is equal to z as per the representation, and then in the x axis you take time, and then you plot the points, and then you will obtain a straight line. Okay, where intercept is at time t equals to 0. Okay, intercept is at time t 0. Okay, 0 days. So then you will obtain a straight line, and then you put your slope. Okay, that is this difference between sorry, you take your slope. Okay, how to take your slope? Slope is your y2 minus y1 divided by x2 minus x1. Okay, also denoted by tan theta, so you can easily get your slope, and then you can easily get your intercept. Okay, so with that, okay, we know the values. Now with that values, we can easily get the values of k dash l naught and k. Okay, so we know what are the values of a and b. Okay, so a and b values are known to you. This is a, okay, and your slope is your b. Okay, a is the intercept, b is your slope, so you know values of slope and intercept, so you substitute everything. Okay, then you will get your the equations for k dash l naught and your k. Okay, so I hope that is clear to you. So this topic is finished here. Okay, so in the next class I will provide you notes regarding the numericals that will cover these topics. Okay, the topic of your rate constant and ultimate BOD. Okay, there will be numericals from your most important method is your least square method and Thomas-Loeb method that we have covered. Okay, and there are many methods as I have given you in the first slide. Okay, but the most important method, two methods in with respect to your undergraduate course is your method of least square and Thomas-Loeb method. So on this method, on these two methods, we will solve some two numerical in the next class. Okay, so I will give you the notes so you can go through, and then you will understand how the numerical is done. Okay, so with that said, thank you. Okay, have a great day ahead.